Hey guys, today's video is about piecewise functions. And if you look at the image that I dropped in there, it is a puzzle piece, hence the name piecewise functions. Our goal for today is to be able to graph piecewise functions, and I want you to be able to write the equation of piecewise functions. So let's get started. A piecewise function is a function which is defined by sub-functions that each apply to in a specific part of their domain. So the graph is broken into little pieces. This is why it's called a piecewise function. So you have this graph that's broken into little pieces or parts, and that is called a piecewise function. Okay, graphing a piecewise functions. What steps do you need to do and what steps do you need to take? I want to do a quick reminder for you about some inequality signs, because you're going to see those in piecewise functions, and we have to remember what inequality signs meant. Remember when you had a greater than or less than symbol, you would have a open circle at whatever the point was. So it would be an open circle, okay, at the point. Now, when you had a less than or equal to or greater than or equal to symbol, you would have a closed circle at that point, okay? So the difference here is that equal to, right? When we see that it's or equal to, that is when it's going to be a closed circle. If it's just greater than or less than, we'll have an open circle at that point. That's important when we're dealing with piecewise functions. Okay, so below I have an example of a piecewise function, and today we're only going to focus on piecewise functions that are linear. So everything we see will be a line, okay? It's only going to be a line. We're going to go through the steps of graphing piecewise function, but I want to make a couple edits in our steps, okay? The first step says draw boundary lines at the breaks, and I'm going to say that you draw your boundary points at the breaks. So let's edit that to, we're going to draw our boundary points first. And then we're going to move to step 3, okay? And you'll see what I mean here in a second, but we're going to skip to step 3, where we decide if our boundary points are going to be an open circle or a closed circle based on the interval that they give us in the piecewise function. So we're going to go right on to step 3, and then we'll go back up to step 2 and step 1, where we graph the line for the given interval. Basically what Ms. Bennett is saying is when you graph piecewise functions, graph your boundary points first, then graph the pieces of the function. So graph the intervals of the function. All right, so let's start with this example. My boundary points is going to be where the disconnection happens, okay? I notice if I look at both parts of this piecewise function, the disconnect is happening here when x is at 0, okay? I can tell this because I got one part that says when x is less than 0 and another part saying when x is greater than or equal to 0. So what I'll do first is I'm going to go ahead with my red pen. I will input my boundary point, which is 0, into the first function to figure out where that point is, okay? I know the x value of that point is going to be 0, so I will write a 0 on the side to notate that. I will find f of 0 for the first part of the function. The first part. So I'm going to go over here. I'm going to find f of 0 for my first piece, which is 2 times 0 plus 1. I figure out that f of 0 is going to be 1, right? 2 times 0 is 0 plus 1. So I know f of 0 is equal to 1. Well, what is f of 0? Well, f of 0 is just y. So I know at the point 0, I will be at 1. And this is for the first part of my piecewise function, which is when x is less than 0. All my x values in the domain that are less than 0 are going to be up here at 2x minus 1. So I'm going to go ahead and plot this point first, 0, 1. And I look and its x is less than 0. That means that I'm going to use an open circle, right? Because it's a less than. So I'm going to go to 0, 1, and instead of putting a closed circle, I'm going to put an open circle right there at 0, 1. Now, I'll go back. I'm going to do my boundary point, and I'll use another color. Let me X this out. I'm going to do my boundary point again, but this time I'm going to do it when x is greater than or equal to 0. Okay, so now I will plug 0 into the second function that's greater than or equal to 0, and I'm going to find f of 0. Well, f of 0 of that function is going to be 2 times 0 minus 1. I can quickly see that f of 0 for all my values that are greater than or equal to 0 is going to be negative 1. So the point that I'm looking at for values greater than or equal to 0 is going to start, the boundary point will be at 0, negative 1. Now I'm going to go ahead and plot that point on the graph, and I'm looking, because this value was greater than or equal to 0, I need to now put a closed circle instead of an open circle. So I'm going to 0, I go to negative 1, and this time I'm putting a closed circle on that graph. And now the next step is to graph the interval for the first part of the function. Well, the first part of the function is going to be the 2x plus 1 if x is less than 0. And all I'm going to do now is just graph the line, right? And I just need a point on that line when x is less than 0, okay? So I'm going to substitute a point in for x when x is less than 0. Well, if I think about it, a point when x is less than 0 is negative 1. So I'll take the first line, that first line, and I'll just find f of negative 1 of the function. And I got to plug it into the top because that's when x is less than 0. So f of negative 1 is 2x minus 1, or 2 times negative 1, I'm sorry, plus 1. There we go, 2 times negative 1 plus 1. So I know f of negative 1 is equal to, well, that would be a negative 2 plus 1 is going to be a negative 1. All right, so f of negative 1 is negative 1. So now I have a second point here, and that's going to be when x is negative 1, y is negative 1, and this is for all my values less than 0, which was this boundary point here where my open circle was. So I can go ahead and plot that point, and I'm going to do it in red. Negative 1, 1, negative 1, 1, or negative 1, negative 1, sorry, is right here, okay. And I'm going to go ahead and plot that line. Now that I have 2 points, I can go ahead and draw the line. Now, I need to do the same thing for the second interval of the function. Notice that's our last step, okay? So I'm going to just pick a point on that is greater than or equal to 0. Well, we don't want to pick 0 because we already have that point. So let's pick a point greater than 0. That point I'm thinking of is 1. Okay, 1 is greater than 0. Let's plug that into the function and find f of 1. So I'm going to erase this so I can have some more space, and we can have one other point on our line to graph our second interval. Okay, here we go. So I find f of 1 for the part of my function that's greater than or equal to 0, 2x minus 1. And if I do that, I plug 1 into the function, I end up with 2 minus 1, which is just 1. So I know my second point would be at 1, 1. All right. And I'm going to go ahead and graph that point. And then I can draw the second interval. In order to graph a line, I need 2 points. So I'm going over to 1 and up 1, and here is the second part of my piecewise function. Okay, so the steps: graph your boundary points, determine if they're open or closed circles, then find another point on your interval and graph each interval. Okay, let's go to the next examples where you are going to try to graph these yourself. All right, guys, notice for the first one, your boundary points. Okay, so notice where the break happens. I want you to take a second and I want you to go ahead and graph the piecewise functions. First, identify your boundary points and identify where you're going to plot those on the line, and then graph the intervals of the piecewise function. All right, how did you do? What I started to do was to graph my boundary points. I know the break is happening at x equals -1 because we have where it says the values where x is less than -1 and the values where x is greater than or equal to -1. I'm going to see where the breaks exactly are by inputting into the top part of the function, or my values when x is less than 1, my -1 point. And that's what I did. When I did that, I got an output of -2. Okay, so I know f of -1 for all the values less than -1. That boundary or that breaking point will happen at -1, -2, and I know it's going to be an open circle because we're talking about less than -1. So I went down to -1, -2, and I plotted an open circle. All right. The next thing I did is found my other boundary point for the second part of our graph, which is the values when x is greater than or equal to 0. I did that by plugging -1 into the function, and I did that over here. You can see it in red. My output was a -4, so I knew the second boundary point for my values greater than or equal to -1 was going to be at -1, -4. And I plotted that on the graph, except this time I used a closed circle for that boundary point because this was greater than or equal to. Now I need to plot my intervals. So I'll go back up to the graph and I am going to get another point on this line, but I want a value less than -1. Well, Ms. Bennett chose -2. So I found f of -2 of the top part of our function, and my output for that was -5. So I know at -2, this graph is going to hit at -5. So -2, -5 is the point, And that's all I need to graph a line. So I'll start at my boundary point of -2 or -1, -2, and just connect it through and graph that point, that line, using the point -2, -5. I did the same thing for my values greater than or equal to 1, except I'm using the top function and it's over here. I picked a point greater than or equal to -1, which was 0. So I found f of 0 using the bottom function. And 0 minus 3 gave me an output of -3. So I know those values that are greater than or equal to -1 would also hit, that line would hit at 0, -3. That's why I plotted that point, and I was able to then graph that line for the values greater than. So again, find your boundary points and plot those, determine if they're open or closed circles, and then graph your intervals. Okay, I want you to try again, pause the video, and try to graph the next graph. All right, let me know how you did. Your boundary points for this one were both at 1, 2. So you had an open circle at the top part of the function, but a closed circle at the bottom part of the function when x is greater than or equal to. So that one should be closed, and you should have an upside down v. One of the points I used to plot my left side of the interval was over here when using f of 0. I found another point 0, 1 and graphed that line, and then the right part I found f of 2 of the function, and I saw that was at 2, 0 and graphed that line. All right, guys, let's move on and talk about how we can write a piecewise function. Okay, for writing a piecewise function, we're going to go through the same steps, except this time we're going to write them. So the first step that we're going to do is write our intervals. Let's look at each one of our intervals. For all of the intervals are bounded by our breaking points, okay? So I notice from -infinity, which is over here, up until I get to x equals 0, I then have a break. So I have a way to write that. I know that my first interval is going to be all the values less than 0, right? So I would just put when x is less than 0. Now be careful. I look at this point. Is it going to include 0? And I notice it's closed in, so it will. So this is not only just less than 0, this is less than or equal to 0. My second interval, I notice it is an interval that starts at 0, right? And it keeps going. We keep going on the x-axis until we stop right here, okay? We stop at 4, okay? So we're looking again at the x-axis to write this interval. So I know this is between 0 and 4, and I'll just write that interval. How do I do that? Well, I put x in the middle, and I know these values for x are going to be in between 0 and 4. Okay, so when x is greater than 0, it's less than 4. Now let's talk about what it's going to be. Well, I notice at 0, this is an open circle, okay? So that's just going to be when x is greater than 0. But over here at 4, I notice it's a closed circle. Okay, so that's going to be when x is less than or equal to 4. Last interval is at 4, and it goes all the way out to infinity. Okay, so if I have to write this interval, I know that this interval is going to be when x is greater than 4. And here's the deal, guys, with this one. I know that it is just greater than, it's not greater than or equal to, because we have a open circle at 4. Now, the next thing I want to do is work each interval. So I want to look at my first interval when x is less than 0, and I just want to write the equation for that line. We know how to write equations for the line. The easiest one that I see is using the slope-intercept form, because I can easily see the intercept and I can easily see the slope on this one. If I look starting at the intercept, which is at 2, I can count down 1 and go over to the left 1, so fall 1 and run backwards 1. And that tells me that the slope has to be 1 because I end up on the line. So m is equal to 1, and my y-intercept, or b, is equal to 2. So if I have to write this function for the first line, it's going to be f of x is equal to y equals mx plus b. So m is 1, x plus 2, or in this case, we say f of x is equal to x plus 2. All right, the second part of the function will do the same thing. I'm going to look at this interval here between 0 and 4, and I'll go ahead and write what this line is. Again, I'm still going to use my y equals mx plus b, my slope-intercept form, because I see the intercept, and I can easily see what this slope is. Notice the slope for this is at 0, okay? So my b is equal to 0. I know that, or I'm sorry, the y-intercept is at 0. My b is equal to 0, and my slope for this, I go up 1 and over 1, up 1 over 1. I know my slope for this line, or my m, is equal to 1. So another function, I would say f of x is equal to that y equals mx plus b, right? I'm just rewriting the slope form. So my m would be 1x plus b, which is 0. I can simplify this down, and I know that this is just f of x is equal to x. The last one, I don't want to do slope-intercept form because I don't see the intercept. I'm sure we could find it easily, but I don't see it as easily as the other two. So I want to use point-slope form. I'm going to use y minus y1 equals m times x minus x1. And when I do that, when I use my point-slope form, I end up inputting for m. I can see that the slope, again, let's count. We go up 1 over 1, up 1 over 1. So the m, or the slope for this, is 1. And then I'll just use a point. The point that I'm going to use is the boundary point, 4. And it looks like it's at 4, 2. So I'm going to use the point 4, 2 and plug that in to find the equation of this line. So I would have y minus 2 is equal to 1 times x minus 4. And if I look at that, that simplifies to y minus 2 is equal to x minus 4. And I can put this in mx plus b form by just moving the 2 over. So I'll add 2 to both sides. And I'm going to write this in function notation. So I'm going to change that y to f of x. And I'll say that f of x equals x minus 2. All right, x minus 2. Now let's put it all together as a piecewise function. We're going to take the first part, f of x. We only need to write that one time, okay? So I have f of x is equal to, now I'm going to write all of my intervals. Here's my first interval, which is x plus 2. And then let's write the restrictions on that interval. If we scroll back up, that was when x was less than or equal to 0. And so I'll write that. That's when x is less than or equal to 0. My next interval is x. So I'm just going to write x. And I'm going to go up and write the restrictions for that. That's when x is between 0 and -4. I have to be careful how I write that because I want to include my greater than or equal to signs correctly. So x is greater than 0 but less than or equal to 4. All right. The last interval is x minus 2. All right. And I will just write that underneath, x minus 2. And the restriction or the boundary on that was when x is greater than 4. So I just write that here, x is greater than 4. And then I'll put a bracket on here because these go together. And I have wrote my piecewise function. Okay, I want you to move on and I want you to try writing the piecewise function by yourself. All right, look at that function, check your work. Let me know if you got it. If you did, give yourself a pat on the back. You're in the right direction. All right, when we come to class tomorrow, we'll practice graphing some more piecewise functions, and then we're going to up the ante a little bit. We'll do piecewise functions that are a little more complex. I'm going to include some of our parent graphs in our piecewise functions. All right, guys, see you tomorrow.